Hey guys, welcome to lesson 1.2. Today we're going to talk about the cumulative and associative properties. Your aim in this lesson is that you can explain the reasoning behind combining linear expressions using the cumulative and associative properties. Let's take a look. Numbers combine through operations of addition, subtraction, multiplication, and division to produce other numbers. You've done this before by saying 3 plus 3 is 9, 9 minus 3 is 6, and so on. Sometimes how they combine is dictated by convention, like with order of operation. Convention is basically saying how we do something. Other times, though, properties about numbers exist simply due to how these operations work, and I'm going to explain what this means. Let's take a look at exercise 1. Add the following numbers without using a calculator. So put your calculators away, and let's take a look at this expression without a calculator. The hint, although order of operation tells us we should add from left to right, think about an easier way to sum these numbers. Let's show how you summed them. So I could just do 3 plus 9 and get 12, plus 4 and then get 16, then plus 2 and 18, but that's going to kind of take a while, and right? There's a much easier way if we can look for grouping. So let's think about grouping these numbers. What's an easy thing to add up together to get a good number? Numbers like 10. 10 is a great way. Things that add up to 10, 1 plus 9, 2 plus 8, right? We know in our heads what kinds of numbers add up to 10. So I'm going to take a look here. I'm going to get a different color on my pen so I can show you. I see that if I combine 3 and 7, I'm going to regroup them so they're next to each other. That's 10. Let's think of something else that combines to 10 there. How about the 9 and the 1? So let's cross them out and regroup them here. Plus 9 plus 1. How about that 4? What can it group with to get 10? The 6. So plus 4 plus 6. And then finally look what's left over. What's 2 and 8? That also gives you 10. Now suddenly this problem has become much easier because I have grouped them with numbers that add up to 10. So 7 plus 3, 10. 9 plus 1, 10. 4 plus 6, 10. And 2 plus 8, 10. All I did was group this, so now the addition is much easier, which is what the problem was originally asking us to do. What is 10 plus 10 plus 10 plus 10? 40. And that's much easier than doing it the original way, trying to go from left to right. We used grouping here. Addition and multiplication have two very important properties with very technical names. The next exercise is going to review those properties. Now you need to memorize these terms, and it is part of your vocabulary, which we are going to talk about, and you're going to make flashcards for. But let's take a look at it here in the lesson. So exercise 2, fill in the blanks for each property. The cumulative property of addition. 8 plus 4 gives the same sum as 4 plus 8. Both sums equal 12. The cumulative property of multiplication. 6 times 3 gives the same product as 3 times 6. Both products equal 18. Cumulative property is basically saying that order does not matter. 8 plus 4 is the same as 4 plus 8. Same with multiplication. 6 times 3 is the same as 3 times 6. This only works in addition and multiplication. The second property is the associative property. The sum, 3 plus 5 in parentheses plus 9, gives the same result as a sum where if I take the 3 outside the parentheses and I put the 5 plus 9. Both sums are equal to, what is 8 plus 9? 17. What's 3 plus 14? 17. Associative part of multiplication, the product 2 times 5 parentheses times 7 gives the same result as a product of if we took the 2 out and multiply it by 5 times 7 now in parentheses. So all I'm doing is taking the grouping symbols, the parentheses, and putting them around different numbers. They'll give the same result. This is 10 times 7, and this is 2 times 35. Both give you an answer of 70. This property is saying that grouping doesn't matter. Right? I can group them and put parentheses wherever I want. in addition and multiplication. The cumulative property, and I'm moving on to the next part, the cumulative property and associative property essentially give us permission, that allow us to rewrite addition and multiplication problems in different orders than what we're normally given. It gives us some freedom to move numbers around, to make it easier for us to do the math. Let's take a look at exercise 3. Give an example that shows that subtraction is not cumulative. Now, let's remember, cumulative means that order doesn't matter. Actually, let me make this a little easier to read. That order doesn't matter. Okay, so let's think of a subtraction problem. I'm going to think of, let's do 10 minus 2. What is 10 minus 2? 8. Cumulative says, the property says that I could move that 10 and that 2 around and say, okay, 2 minus 10 should also equal 8. But it doesn't. What is 2 minus 10? It's negative 8. So this is not cumulative. Even though subtraction is not cumulative, we should remember a very important fact about subtraction. It can always be made into the addition of opposites. And here's what they mean by that. Let's take a look at something like 10 minus 2. That's a subtraction problem, right? I could say that 10 minus 2 is the same as 10 plus negative 2. Addition of opposites. You've got the minus and the plus next to each other. These are the same thing. But sometimes it's easier to visualize 10 minus 2 as 10 plus negative 2. If you input both of these into your calculator, you will get 8 for both of them. The calculator will read them the same way. It's just what you prefer seeing. If this helps you to do an addition of opposites, then by all means go ahead and do it. And we're going to do some examples of what this looks like here. Number 4, change the following expression involving addition and subtraction into 1. So we're trying to take this one big expression and put it into 1, only involving addition. So we want addition symbols. So plus something, plus something, plus something, plus something. And we're going to use the cumulative and associative properties to quickly do this. And while we're doing this, I'm going to review some properties of negative numbers because it's been a while since you've been in math over the summer. So let's take some time and try and rearrange this phrase. So 7 minus 3 is what I'm starting with. What did I do up here where I had 10 minus 2? I put an addition and then kept the subtraction. So I'm going to change this to a 7 plus negative 3. Keep the plus is next, plus 8. I don't need to change that. But then what do I have? I've got a minus sign here. So I'm going to say 8 plus negative 2. Then comes a minus 6, so I'm going to say plus negative 6. There's another plus, so plus 1. And then here's where this kind of gets tricky. This is like saying plus minus minus 3. Now, these symbols are grouping symbols. And what did we just learn about grouping? They can be dropped in addition and subtraction. So I'm going to drop it. And now I'm going to take a look at this. 7 plus negative 3. That is a 4. Plus, what's 8 plus negative 2? 6. Plus, I'm going to cross these off as I do them so I keep track. Plus, negative 6 plus 1, that's negative 5. Plus, what happens here when you have two negatives? What does it become? It becomes a positive. So this is like saying plus 3, right? Two negatives become a positive. It's really important we remember that from middle school, right? Now I've got something a little easier. 4 plus 6 is 10, plus negative 3 plus 3 is negative 2, and 10 plus negative 2 is the same thing as 10 minus 2, which is 8. Okay, so we're talking about grouping, rearranging numbers, and if you do see a minus sign, it's the same thing as being able to put a plus in front of it. It's really important that we keep track of our negative numbers as we go through this year. Negatives will really show up in a lot of problems, and we have to be very careful with them. We should now be able to extend the commutative and associative properties for numbers. We know to numbers, and we don't know, so variables. So this is saying that, hey, the commutative and associative properties work on numbers, but they also work on variables. One of the very nice ways to illustrate the usefulness of these properties is in combining expressions. And combining, oh, I'm spelling that wrong. Combining really means adding expressions or subtracting. I'm sure you've heard the phrase combining like terms. That's kind of what we're doing here. We're combining like terms. Okay? So, letter A, exercise 5 says, recall that the following. So A, I have a 5x plus 2x. These are like terms. They have the same variable. When you combine like terms, you add the coefficients. Okay, so the coefficients are the numbers in front. So 5x plus 2x is going to equal 5 plus 2x. 5 plus 2 is 7x. It's like saying if I have 5 apples plus 2 apples, how many apples do I have? 7 apples. This is the heart of what like terms are, right? You're saying you've got 5 x's and 2 x's. Well, how many x's do I have? I have 7 x's. Can you try B and C on your own? So I'd like you to pause the video, try B and C on your own, and then unpause, and you can see if you got it correct. Okay, let's take a look at what you did. 7x plus negative 3x is the same as saying, the same as saying 7 minus 3x. 7 minus 3 is 4x. Right? I've got 7 apples, and then I take away 3 apples, so now I've only got 4 apples left. Sometimes it's really useful to pretend a variable is something, a thing that you can touch. That way it makes the math make a little bit more sense when you're doing it. So C, I hope that you guys got this correct. Negative 8x minus plus negative 2x. Put this in your calculator. Type in your calculator negative 8 plus negative 2. And what do you get? You get negative 10. So this is like saying negative 8 minus plus negative 2x. So it's negative 10x. Right? I'll put a box around that so you know that's the correct answer. And for your notes, I typed this into your calculator. Using your calculator is important. Don't be afraid to use it. I know Ms. Vasquez has been working with you guys on calculator use, so please listen to her to pay attention to the lesson she's giving about your calculator, because your calculator is so useful, and you can use it on the Regents, so even more reason we should really use it. Okay? Exercise 6. List. In the following exercise, we show how linear expressions are combined using various properties. List what they are. So this exercise is saying, hey, we are starting with this right here. And we're saying, how are we going from this to this? What has happened? Oops, I keep doing that. This is the how. How are we going from the expression on the right to the expression on the left to the expression on the right? What is happening here? Well, what is the only difference between the expression on the left and the expression on the right? The parentheses. And parentheses are grouping symbols. And what property do we use to talk about grouping? It's the associative property. And what operation is happening here? Multiplication or addition? It is addition, so we call this the associative property of addition. Then, notice, over here, all they're doing is rewriting this on the right and putting it down here. These are the same. And now it's asking you, okay, how do we go from this side to the next side? Well, what's the difference? What did they do from the left to the right? Well, they just rearranged the numbers. All they did was they rearranged, and rearranging is the commutative property. And what operation are we doing? Addition. So it's the commutative property of addition. Finally, the last step, again, they're just rewriting on the left what the step before. So what is happening from the left side of this to the right side? Oh, they're just adding regrouping symbols. Whenever you're talking about grouping, we are talking about the associative property. And it's addition, so it's the associative property of addition. If you're not sure, you can always go back to your notes, look at me going back, and I'm saying, well, I forgot what it was. And I'm going to say, oh, look, grouping is associative property. I'm using those grouping symbols. Ordering is commutative property, so I can check my group, my work. Grouping, associative property. Rearrangement, commutative property. So it's really important to go back in your notes, and that's why you have the vocab cards also to help you remember these properties. Finally, let's try just combining expressions below. Replace subtraction by addition of opposites if needed. This if needed is saying, hey, if you need to put in addition signs to help you keep track of your negatives, then please do so. So I'm going to go ahead and do that in my work with you. If you want to not do it on your own work because you've really gotten a good hold of negative numbers, you don't have to. This is just there to help you. That's why it says if needed. So letter A. All right, I'm going to look for my terms that I can group. I can group the 4x and the 2x. I'm going to say 4x plus negative 2x. And I can group the 6 and the 9. So I'm going to say plus 6. Notice I made a mistake here. I just circled the 9, but what's in front of that 9? A minus sign. And I've got to make sure that I keep that minus sign with it. So I'm going to say plus negative 9. Now I can do my adding and subtracting. 4x plus negative 2x, well, 4 minus plus negative 2 is a positive 2. I'm going to cross them off when I'm done. And then 6 plus negative 9 is a negative 3. And I can do that easily by plugging these into my calculator, right? So I'm going to say here, use your calculator when necessary, right? If negative numbers are a struggle for you and you can't do 6 plus negative 9 in your head, that's what your calculator is there for. You'll have the same calculator on the Regent, so don't be afraid to use it. Can you try B and C on your own? Pause the video and try B and C by grouping and combining your terms, and then unpause to see if you got it correct. Okay, welcome back. Let's take a look. I see negative 6x and 10x can be grouped, so I'm going to say negative 6x plus 10x. I also see a 9 and a 3, so I can say plus 9 and plus 3, and I've grouped my like terms. Negative 6x plus 10x is the same thing as 4x. I can check in my calculator by typing in negative 6 plus 10. Cross them, oops, did not mean to do that. Let me rewrite. I'm going to cross these off when I'm done with them, and then I'm left with 9 plus 3, which is a 12, and that is my final answer. And finally, for the last one, I have 4y and a negative 7y. Don't forget that negative, it's really important. 4y plus negative 7y. And then I have a negative 10 and a negative 3. Notice how I circled the negatives. I'm going to keep those negatives. Plus negative 10, plus negative 3. 4y plus negative 7y. That's a negative 3y. Cross them off because I'm done using them. And negative 10 plus negative 3 is negative 13. I'm going to put that in a box. Notice these are my final answers because I cannot combine a 2x and a negative 3. They don't have the same variable. I can't combine 4x and 12. They don't have the same variable. It would be like saying, what's 4 apples plus 12 oranges? Can you say you've got 16 up oranges? No, you can't. You have to leave it as this. Again, like I said, if you're struggling, think of a real-world object that these numbers represent, and that will help you make sense of the problem. Okay, that is the end of Lesson 1.2. Please begin on fluency.